Okay, everybody, time for practice test 2 from textbook chapter 7. So practice test 2. Here we go. Practice test 2 from textbook chapter 7. I think some of you didn't get this, I don't think. So if you didn't, again, we've already done number 1. And it is available in Schoology for you to print or to put into Notability. So if you haven't done that yet, hit pause, go get it taken care of so that you can follow along with us. Those of you that have the sheet, here we go. We are going to start problem 1. It says solve using substitution. Okay, so the directions very clearly say we are to use substitution. Now remember, if you're using substitution, you want to find a variable in there, preferably, that's already by itself. So that would be this y right here. This y is the only one that's already by itself. So I'm going to take that top equation, and I'm going to get the y by itself. So I'm going to move the 2x over. So y equals 5 minus 2x. Then I'm going to take that value of y right there, this guy right here, and he's going to go into my other equation in place of y. Since that's what y equals, he's going to go in there in place of y. So that's going to be 3x minus 2 times my y value, which is 5 minus 2x, equal to negative 3. So I simply solved, got y by itself in this equation, moved the 2x over, and then took that thing, 5 minus 2x, and put it right here in place of that y. So I have 3x minus 10 plus 4x equals negative 3. I just did my distributive property, very careful with my negative sign, negative 10, positive 4. So now I can add these, so 7x equals, let's move that 10 to the other side, and that'll be 7. I'm adding 10. So 7x equals 7, which means x equals 1. Remember, whenever you're solving a system of linear equations, you're looking where they cross. So your answer needs to be a point. So x is 1. Okay? So if I plug 1 back in for x, I get 5 minus 2, which is 3. So the answer to the problem is 1, 3. Now we are going to do exactly the same thing, but we're going to use elimination. So we have a different system of equations, but it's exactly the same idea. Only the directions specify that we must use elimination. This is problem number 2. We must use elimination. Okay? So if we're going to eliminate, that means that we want to add our equations together and make something disappear. Now look, if you add these, you get negative 3. If you add these, you get 4. Nothing disappears. So you're going to have to do something to make it disappear. You have options. You always have options. That's the best part about math. Always lots of options. But probably the easiest thing to do would be to multiply this equation by negative 3. Because if we multiply that equation by negative 3, it becomes positive 15x, negative 3y, and negative 30. Now, what's so special about that? I multiplied the bottom equation by negative 3, so I got 15x minus 3y equals negative 30. That's the second equation. Well, remember, the first equation looks like this. Now, remember what we're doing when we're doing elimination? We're adding them together. Well, this would make 17x, but what happens here? The y's are eliminated. That's what we wanted to have happen. That's why we multiplied by negative 3, so that those would disappear. Equals negative 34. So now we can divide. And it looks like this time my x is negative 2. Negative 34 divided by 17. Now to find y, we'll do what we always do. We'll take our x and plug it back in. So 2 times negative 2 plus 3y equals negative 4. Now, I plugged it in the top equation. You are free to plug it in the bottom equation right here. If you'd rather use this one, I just did that one because it was on top and I had room up here. Doesn't matter. Put your negative 2 either in here or in here. So when I do that, in the top equation, I get negative 4 plus 3y equals negative 4. Well, shoot. When I add 4 to both sides, what happens? I get 3y equals 0. Now, that doesn't mean no solution, folks. If 3y equals 0, that simply means y equals 0. So my answer is negative 2, comma, 0. That is the point where these two lines cross each other. Okay. Guess, oh, what, now we've got the same thing, the exact same problem, but this time, boy, I can't read that very well. This time we are doing Kramer's rule. Okay, so we have we've had 3 problems now. This is the 3rd problem that looks just the same. Got a couple of lines. First we substituted, then we eliminated, now we're using Kramer's rule. So we just have to keep the processes straight in our head. All right, so here we go. What do we do when we have Kramer's rule? What is our strategy with Kramer's rule? Well, step 1, we make a determinant of the letters, of the coefficients on the variables. So 3, 1, 3, 1, negative 2, negative 5. So 3, 1, negative 2, negative 5. All right, so evaluating a 2 by 2 determinant, we know that means 3 times negative 5 minus negative 2 times 1. So this times this times this, subtract. So negative 15 minus negative 2. So the value of the determinant is negative 13. Negative 15 minus negative 2. Negative 15 minus negative 2 gives me a negative 13. So x is something over negative 13, and y is something over negative 13. So now I have to evaluate those little determinants for x and y. Well, to find them, I am going to use these two numbers. I'm going to pretend that I can cut those out, 7 and 1, and paste them either on this column or on this column, depending on if I am solving for x or y. These are the x numbers, so the 7 and the 1 are going to go on top of the x if I'm up there. So that's going to be, here's the 7 and the 1 right there, and then I still have the 1 and negative 5. So I cut off the 7 and the 1 and put it right here. So it's 7, 1, 1, negative 5. And then when I do y, I do the same thing, only the 7 and the 1 go here. So it's 3, negative 2, 7, 1. I am literally cutting these out and pasting them on top of the one I'm solving for. Okay? Now, let's evaluate those determinants. I don't have much room. I'll try to squeeze it in up here. That's going to be negative 35 minus 1. Negative 35 minus 1. So that numerator is negative 36. So x is negative 36 over negative 13, or 36/13. it's negative 35 minus 1, so negative 36 over negative 13. The negatives cancel, 36 thirteenths. Now y is 3 minus negative 14. So it's 3 times 1, 3, negative 2 times 7, negative 14, and then subtract. So 3 minus negative 14 is 17 over negative 13. This is 17, 3 minus negative 14 over negative 13. And there is the answer to that one. Wow. Kramer's rule. All right. Next page of the practice test is full of matrix operations. So I'm not going to copy all the matrices down. They take up too much space on my little board here, but you've got them there in front of you. And so the first one, it's hard to read. It says A inverse. We want to find A inverse. And matrix A is that. So we're going to find the inverse of that matrix. Now, I know I keep saying this. There's so much to remember, guys, but you've got to somehow keep it all straight. To find the inverse of the matrix, we first of all have to find the determinant. So we've done that a lot tonight, already a couple of times. So we're going to find the determinant of A. So the determinant of A is negative 4 minus 6. So it's 1 times negative 4 minus 3 times 2. So the determinant is negative 10. Negative 4 minus 6. Negative 4 minus 6. Now the second step is we're going to create a new matrix. And remember, the new matrix is found just by manipulating things, not by doing any math. We simply take these two right here. Look where my fingers are, please. Take these two right here and flip-flop them. So we put negative 4 here and 1 here. We just flip-flop these two. And then these two, we leave them where they're at. So that stays 2 and that stays 3. But since that's positive, it becomes negative. Since that's positive, it becomes negative. These two numbers, remember, stay right where they are. You just change their signs. Okay, then you remember what to do now that you have found the determinant. That's step 1. You've created the new matrix by doing the old switcheroo and changing signs. What happens now? You take each of these, all these numbers right here in your new matrix, and divide them by the determinant. So we have negative 4 over negative 10, negative 2 over negative 10, negative 3 over negative 10, negative 1 over negative 10. And then you clean it up, and that is the answer to the problem. So negative 4 over negative 10 would be positive 2/5. Negative 2 over negative 10 would be positive 1/5. Negative 3 over negative 10 would be positive 3/10. And 1 over negative 10 would be 1 over negative 10. And that, my friends, is the inverse. Awesome. All right, question B is much easier. B says, take 2 times matrix C. And this is matrix C. Okay? So that's easy. All we do is take 2 times matrix C. All we do, remember, is multiply each number in the matrix by whatever's out in front. So in this case, it's 2. So that number, by the way, is called a scalar. It's one of your vocab words. So we take 2 times 1, 2 times 2, 2 times 3. 2 times negative 1, 2 times 1, 2 times 4. Done. We should not miss that. That is pretty darn easy. All right, now we're going to multiply. So it says A times C. So that's matrix A times matrix C. Okay? Now, before we start in, we got to make sure we can even do this. Okay? So to make sure we can do it, we're going to figure out what the dimensions are. So remember, it's rows and then columns. So how many rows do we have? 2. How many columns do we have? 2. So this is a 2 by 2. All right, how about this guy? How many rows do we have? 2. How many columns do we have? 3. Now, these two matrices could not be added if we were adding them, but we're not adding them, we're multiplying them. And since these match, we can multiply. The rule for multiplication is these two have to match, and they do. We know then that our answer will be a 2 by 3. So I'm going to write it down here. This is going to be my answer. It's going to have 2 rows and 3 columns. And then you know, because we've done so many of these, that I like to give myself a little code down here, a little hint. You don't have to do this. These numbers are not part of the answer. They just help me remember what I'm putting together to get these numbers. So this guy's in the 1, 1 spot, row 1, column 1, row 1, column 2, row 1, column 3. All these numbers are in row 1. All of these are in row 2. So row 2, column 1, row 2, column 2, row 2, column 3. Again, those numbers are not part of the answer. I'm going to erase them later on. They're just helping me figure out what I am going to multiply. So, right here, this guy right here says multiply row 1, column 1. So row 1, column 1. So I write down the numbers in row 1, 1, 2. And then I write down the numbers in column 1, 1, negative 1. And then I multiply the pairs and add them up. So 1 times 1, 2 times negative 1, add them up. So that's 1 minus 2, that is negative 1. So the number that goes in that spot is negative 1. 1 and negative 2. Okay? Now I'm going to move over here to this column. First row, still using the first row, but now I'm using the second column. So I'm going to write down my 1 and 2, and now my 2 and 1. So I wrote down my first row, 1 and 2, and then my second column, 2 and 1. So these are my row numbers. Right here, these are my row numbers, 1 and 2. These are my column numbers, 2 and 1. So that number in that spot is a 4. 2 plus 2. And finally, in that top row, I'm still going to use my first row, but now I'm going to use my third column. So I write down my 1 and 2, and then 3 and 4. So my 1 and 2, there they are right there, my 1 and 2, and then my 3 and 4 right here. So 3 plus 8, that's going to be 11. So now my top row is done. So I'm going to go down to the second row. Now I will be using my second row of numbers, which is 3, negative 4. So I'm going to use 3, negative 4 with my 1, negative 1. Second row, first column. 3, negative 4, second row. 1, negative 1, second, or first column, second row, first column. All right, let's add them up. That's 3 plus 4. That's a negative times a negative, so it's going to be plus. So that number is a 7. second row, second column. 6 minus 4, 6 and negative 4, that would be a 2. And finally, second row, third column, 3, negative 4, times 3, 4. 3, negative 4, there's my row. 3, 4, there's my column. So what is that? 9 minus 16, so negative 7. There is the product of those two matrices. Okay, what's next? Next, we have A plus B. Now, I'm not going to write these out because hopefully you've noticed the dimensions of A are 2 by 2. The dimensions of B are 3 by 3. Can these guys be added? Can they be added? No, they cannot be added. So problem 4, or D, I guess it is, problem D, that says A plus B is not doable because in order to add or subtract matrices, they have to be the same size. So if you want to add them, they'd have to both be 2 by 2s, or both be 3 by 3s, or both be 5 by 8s, or both be 11 by 16s. Doesn't matter. They just got to be the same if you're going to add them. Now, I think E is going to be problematic also, because E says take B times D. Now, B is a 3 by 3, and D is a 2 by 2. Those cannot be multiplied, because remember, the rule for multiplication is these have to match. That's the rule for multiplication. They don't match, so E is also an empty set. Don't be alarmed. Empty sets happen a lot in matrix land because the rules are so specific about who can be added, who can be multiplied, whatever. So D and E are both impossible problems. All right, but what about F? F says take 2D minus A. Now notice that D is a 2 by 2. And we're going to subtract A, which is also a 2 by 2. This is problem F, and it is doable. F is a doable problem because you got a 2 by 2 minus a 2 by 2. That's very, very doable. However, before you start subtracting, you got to take care of this. We have a scalar sitting out here, so we're going to have to clean that up. So that's going to be negative 4, 2, 6, 12. For those of you in La La Land, hop, hop, we already talked about this. 2 times negative 2, 2 times 1, 2 times 3, 2 times 6. Now we're going to subtract. And that means that we are going to subtract corresponding entries. So to get the number that goes right here, this guy right here, to get him, we're going to subtract negative 4 minus 1. Now this is a subtraction. So negative 4 minus 1. Negative 4 minus 1 is negative 5. Two minus 2. 2 minus 2. 0. Six minus 3. 6 minus 3. And finally, watch it. 12 minus negative 4. 12 minus negative 4. 12 minus negative 4 makes 16. And there is the answer to your question. Okay. that page is done. Now we have a determinant to evaluate. So it's a 3 by 3. You all should be really good at this. This should not be a problem. This should be an easy question for you. Make sure I get it copied right. Alrighty. So what's our procedure for evaluating 3 by 3 determinants? Well, remember, we're going to take the first column and write it right here. Columns go up and down. Take this set of numbers, copy it right here, and then take the next one and do the same thing. So we have simply recopied the first two columns right out here to the right. Now we're going to start right here and we're going to multiply straight down this diagonal. So what happens when we multiply those three numbers? We get 0. And then we're going to multiply these three numbers and we also get 0. And then we're going to multiply those three numbers and we get -4. Now let's total those up. We have a 0, and a -4. So that gives us -4. You aren't done. Now you got to come over here and do the same thing. Multiply those together. We get 0. Multiply these together. We get 10. And multiply these together and we get another 0. So we're multiplying 0, multiplying 10, multiplying 0. Now total them up and we get 10. Now we have two answers. We have our red multiplications that totaled up to -4. We have our green multiplications that totaled up to 10. What do we do to get our final answer? We subtract those two numbers in order. So -4 minus 10. The answer to the problem is -14. The value of that determinant is -14. Now we have our vocabulary section. So we've got a matrix given. And then we're asked some questions about it. This is matrix A. And the first question is A sub 1, 2. Now remember, the little a simply refers me back to matrix A. It says look inside matrix A. This is the row and the column. It's always R or RC, always row, column, Roman Catholic. So we have the first row, second column. So what number is in the first row, second column? Right there he is. So that entry, the entry in the 1, 2 spot, first row, second column, is 4. What are the dimensions of that matrix? The next question says, what are the dimensions of matrix A? Well, how many rows does it have? 4. How many columns does it have? 2. So matrix A is a 4 by 2. Rows go across, rows of the bleacher, columns go up and down, columns of the White House. C says, it doesn't want you to tell me what 3A is. It says, what do we call 3? What is the name we give for 3? If you say coefficient, you're not going to get credit because even though it does look like a coefficient and act like a coefficient, we're in matrix land. And in matrix land, that's not called a coefficient. It's called a scalar. By the way, the vocabulary we use in vectors, which are our next unit, that vocabulary will be exactly the same. So we'll call that a scalar, even when it's attached to a vector. Is A a square matrix? Is this a square matrix? Now you're going to have to explain your answer. So think about what you're going to write. Well, first of all, I hope you say no, it's not square. And why is it not square? Because it does not have the same number of rows as columns. To be a square matrix, you must have the same number of rows as columns. To be a square matrix, you must have the same number of rows as columns. Okay? And then E says to find matrix. Guys, that exact same question was on the last practice test. A matrix is a rectangular array of numbers arranged in rows and columns. I don't know how to say it, guys. If you missed that, you just ought to be kicked in the seat of the pants, because that same question now has been on both practice tests. So definitely I would know what the definition of a matrix is. A rectangular array of numbers arranged in rows and columns. Alrighty, now we have our linear programming problem. Alright. The numbers are on there, it must be number 7. Problem 7 is all by itself, a whole page, and it's our linear programming. So let me get my chart set up. And while I'm getting this set up, why don't you see if you can read the problem, and then maybe start filling in some of these blanks. Okay, so we're reading the problem. Have you how many of each type should be made to minimize cost? So this one is going to be a minimum problem, and we're going to be minimizing cost. Now I need some variables to find, so I am going to let X be the number of audio players and Y be the number of phones. So X is going to be the number of audios and Y is going to be the number of phones, because that ultimately is what the question's asking me. That's the very last part of the question. How many of each type should be made? So that's my X and my Y. How many number of audios, Y equals number of phones. All right, so let's start putting in some of these numbers. It must make a minimum of 600 audios and 800 phones, and a maximum of 1,500 audios and 1,700 phones. Now, stop for a minute and think. That means that your audio players have to be between 600 and 1,500. Look at that second line of the problem. You have a minimum of 600 audios and a maximum of 1,500. So your audios have to be between, I know I don't have enough room here, so this is going to expand out, but have to be between 600 and 1,500. That is this box right here. That goes with the X's. Okay, all that goes here. Your box is bigger than I didn't draw mine big enough, but there it is. Now, what about the phones? What do I know about the phones? Well, the phones have a minimum of 800 and a maximum of 1,700. So your Y's are in, your Y's are in that range right there. So your X's are between 600 and 1,500, and your Y's are between 800 and 1,700. What are our costs? 55 for an audio, and 95 for a phone. What do I do with the 2,000? At least 2,000 items must be produced per shift. Isn't that the total number? Doesn't the total number have to be at least 2,000? So these two spots are empty. We're not panicking about that. This one's always empty. And this one often is, so we're not worried about it one bit. All this red goes in this box. All this blue goes in this box right here. And those are our fixed intervals. So we're going to graph those. So my blue equation looks like this. My red equation looks like this. What's that top equation? Now be careful. You really got to read the question. It says at least 2,000 must be produced. So whatever x and y are, they actually have to be greater than or equal to 2,000. We have to have at least 2,000. The two that are gimmies, you don't even need to write those down because of the fixed interval that's given, but it doesn't hurt anything. Might as well write them down every time. And then what's our cost? 55x plus 95y. The cost of an LIDO is 55, so 55 times x plus 95 times y. Now you can probably tell by the size of those numbers that we're going to need to make some adjustments to our scale, because your graph's not big enough, my graph's not big enough. We're going to have to make some adjustments to the scale. Remember, we've talked about this every time we've done one of these. If you need to make your graph bigger, extend the lines, make more boxes, perfectly fine. Do it. Don't get confused or sweat it. Just make your graph bigger if you need it. Now, I got to decide, these are really big numbers, guys. These are really big. So I am thinking I'm going to use a scale of 100. Wow. And if I use a scale of 100, I have just barely enough. So I'm going to use a scale of 100. Okay? Now, for the blue equations, remember, if it only has a y, then you only plot on the y-axis. So if I'm using a scale of 100, I'm going to go up 8. And up 17. And I'm going to draw horizontal lines. Remember, they're not diagonal because you don't have any x's. So you don't have any points on the x-axis. I just counted up to 8. That represents 800. Up to 17. That represents 1700. And then I went straight across. I'm on the y-axis because that blue equation involves y. And I'm going to shade everything in between that bar, okay? Now, my red equation is on the x-axis. So for my red equation, I'm only looking at my x-axis. So I'm going to count over 1, 2, 3, 4, 5, 6, and 7, 8, 9, 10, 11, 12, 13, 14, 15. And those are the points 600, 0, and 1500, 0. Okay, so the red equation, I am only on my x-axis. Okay? And I'm going to take a line straight up. Geez, they're supposed to be straight. I'm just not a very good straight line drawer. And now I'm between my reds, so I'm basically looking at this box right here. It's in between the horizontal blues, in between the vertical reds. So it's that box right there. Okay? Now on top of that, I got to throw in my green line. Now my green line has both letters. So remember how we do this. We cover one up at a time. So if we let x be 0, y is 2,000, which would be 20 on our scale. So I'm going to count up 20. So I'm clear up here. Green dot clear up here. Count up 20. If you're using my paper, you're obviously extending your line up so that you can get 20, all the way up to 20. And then if we cover up y, x is going to be the same thing. So I have a point clear up here where y is 20. And then clear out here where x is 20. So now I'm going to connect those two as straight as I can. I'm using my paper as kind of a straight edge to help me, because we know I don't draw very straight lines. And there I've connected them. Okay, now where is that green line shaded? Pay attention. Where's that green line shaded? That green line is shaded above. So I'm going to shade everything inside my box. So between my reds, between my blues, and above my green. So I'm going to shade all that in. So I'm inside the box and above the green line. Notice that I have 5 vertices. I have 5 corner points. Now we have talked about this many times, that some of those corner points are always, always, always easy to locate. For example, look at this one right here. It's on the corner of the top blue, which is 1700, and the first red, which is 600. So this is the point 600, 1700. That's this point right here. Similarly, this one is exactly the same, only its x is 1500. So this is 1500, 1700. Now, please don't be confused, kids. That point is where this line and this line come together. This is where x is 1500. This is where y is 1700. Likewise, this one right here. This is where x is 1500 and y is, oops, my thumb got on top of it, but y is 800. So this is 1500, 800. So far, I'm going to write them up here. So far, we have identified the 3 corner points that are so easy: 600, 1700, 1500, 1700, and 1500, 800. Okay? Now, the next 2 aren't quite so easy, but they're still pretty easy. This guy right here. Look where I'm pointing, right here. That point is on this blue line. Oh, I erased my, oh shoot, I erased too much. That point is on the line where y is 800. right? I shouldn't have erased those. So let me get those back up here. 800. And what was my red? My red was 600, 1500. And then my green was x plus y is greater than or equal to 2000. I really need those to help me figure this out. So, sorry about that. There we go. So now, here I am, right here. I'm looking at this point right here. Right here. So I know my y is 800, but it's on the green line. And any point on the green line has to add up to 2000. So if I know that my y is 800, because I am on the y equals 800 line right here, if I am on the y equals 800 line, but I also have to add up to 2000, then I know x must be 1200. Because 1200 plus 800 will give me my 2000. And then that last point, we're going to do exactly the same thing. It's right here. It is on the line where x equals 600. And if x equals 600, but it has to add up to 2000, then that must be the point 600, 1400. Remember, if you are a point on the green line, then you must add up to, your coordinates must add up to 2000. So we knew, for this point right here, we knew that x was 600. Well, if the x is 600, and we have to add up to 2000, then y must be 1400. Now, I also erased my cost expression. My cost expression was 55x plus 95y. And that's important, isn't it? Because now I'm going to take each one of these points and plug it into this expression. So I'm going to take 55 times the x and 95 times the y and come up with a value for each of these points. Obviously, I'm using my calculator to do this. So one more time, I'm going to be quiet here and let you type all this in. But you are simply taking, these are all x's and y's. These are x and y ordered pairs. So you're going to put your x value in here and your y value in here and figure out what it is. Now I can erase these to give myself some more room. Boy, I miss my big board. Now, I don't know, have you gotten this far? remember, I've erased it now, but remember, we are actually this time looking for the minimum. This is the cost of producing these things, and we want the minimum. So when we look at these values, it looks like this one right here is our minimum. Gave us the lowest cost if I didn't make any mistakes. So we will write our answer then. After all this work, do not shortcut it. Write your answer. The company should make $1,200 audio players and 800 phones for a cost of $142,000. Don't whine and complain about having to write an answer. Good grief, you just did a ton of work. Okay, one more problem. This is your calculator problem. So to do your calculator problem now, remember it's real easy. You got to write down the matrix you're going to put in and the matrix that's going to come out. You know what? I think my marker might be running out, guys. Good thing I have more. Never fear. The magic button we're going to use in here is RREF. And ultimately, we're going to come out with an answer, which in this problem is going to be an A, a B, a C, and a D value. Those are our variables, A, B, C, D. So when you write down the numbers that you're going to put into the calculator, here's what I need you to be very careful about. They're going to go in order, A, B, C, D, and then the number, the equals number over here. If you don't have something, like if you're missing an A, then you got to put a 0 in that spot. So make sure you're putting everything in the right spot. So the top equation, 1A, 1B, 1C, 1D equals 10. There's the top row. You have 1A, 1B, 1C, 1D equals 10. Now we have in the second equation 2 A's, negative 1B, negative 1C, negative 3D, and negative 15. So 2A minus 1B minus 1C minus 3D equals negative 15. Now I left you a ton of space on this paper. You spread your stuff out. I don't have that luxury. Spread it out. Okay, now next equation, third equation. We have 4 A's, 2 B's, negative 5 C's, no D's equals negative 7. So 4 A's, 2 B's, negative 5 C's, no D's, negative 7. And finally, we have 1A, no B's, negative 3 C's, 5 D's, and 12. So 1A, no B's, minus 3 C's, plus 5 D's equals 12. So that is the matrix that's going into our calculators. So here we go. That matrix is going into our calculators. So here we go. Second matrix. I'm going to click across to edit. Whoops, click across to edit. It says, what are the dimensions of the matrix you want to put in? Well, what are the dimensions of my matrix? How many rows do I have? I have 4 rows and I have 1, 2, 3, 4, 5 columns. So I'm going to put in 4, enter, 5, enter. Now the calculator simply wants me to put in all of these numbers. So I just start typing in my numbers. I just start typing 1, enter, 1, enter, 1, enter, 1, enter, 10, enter. Remember, oh crap. If you have other numbers in there, you just type over them. It'll be fine. Got some technical difficulties here. Keep typing. Keep typing. Okay, where am I at? Okay, I'm sorry you had to wait on me. I had some more technical difficulties. After you get in that last 12, after you get this number in right here, and you have pressed enter, then you're going to second quit. So press second quit. And then go back into your matrix. So second matrix. Go over to math. Click all the way down to RREF. Press enter. Then back into second matrix. Enter. So now, I don't know if you can see it, it's kind of dark. It says RREFA. Press enter. And the answer comes out, the matrix comes out like this. That is the matrix. Whoops. That is the matrix that should have come out on your paper, on your calculator. If you didn't get that, then go back and retype in. You probably just messed up a number over here somewhere. It's easy to forget a negative sign or something like that. Then you write your answer. That top equation says A equals 1, B is 2, C is 3, D is 4. Isn't that cool how that worked out that way? And that, friends, is the answer. If you had trouble with that, I know we had some technical difficulties along the way, go back and rewatch the lesson video from the notes and start typing them back in. All right, that's it. Thanks.